Hi, 8th graders. This is a math video for lesson 11-7, dealing with precision and also dealing with something known as significant digits. I'm going to create two rulers here. The first ruler is a ruler that I want you to think about in terms of inches, and the second, or centimeters rather, and the second one in terms of inches. As you may hopefully know, centimeters is part of the metric system, and the metric system is based on groups of 10. Our typical rulers are not based on groups of 10. So I'm going to show you precision on both of these types of writing instruments. Now, as you may know, a centimeter is about yay long. But for the sake of argument on this, I'm going to draw this so that the centimeter is a little bit bigger than what it is in real life. And I've created a ruler. Let's imagine that this ruler is measuring centimeters, and somebody says to you, well, how precise is that ruler? And what I would say is that this ruler right now is precise to the nearest centimeter. It's precise to the nearest centimeter. Okay? To the nearest centimeter. In other words, if I had something that was this long, I could say that it's about 1 centimeter long, or I could say it's about 2 centimeters long. But since this line ends closer to 1 than it does to 2, I would say, it's closest to 1 centimeter. I'm being precise to the nearest centimeter. But what if I do this? What if I put a tick mark here, here, and here? Now how precise is my centimeter ruler? I would say that it's precise to the nearest half a centimeter, because what I did is I divided each one of these sections into 2 sections, right? From here to here is half a centimeter, from here to here is also a half. The 2 halves make a whole. So now, instead of being precise to the nearest centimeter, I would say that it's precise to the nearest 1/2 of a centimeter, or it's precise to the nearest 0.5 centimeters, because 0.5 is the same thing as 1/2. Now, on a centimeter ruler, oftentimes they'll do this. And how many sections did I divide each centimeter into now? Well, if you look between here and here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sections. And between here, there's 10 sections. And between here, there's 10 sections. Be careful. Don't count the tick marks. Count the sections between the tick marks. So how precise is my ruler now? Well, it's precise to the nearest 1/10 of a centimeter. Or it's precise to the nearest 0.1 centimeters, which is the same thing as 1/10. That is the number 1/10. They're the same numbers. Okay? Now, with inches, they do it slightly differently, and hopefully you're aware of that already. We can divide inches, well, first of all, let's say we had a ruler that looked just like this. How precise would that ruler be? It would be precise to the nearest inch, right? To the nearest inch. But if I put a tick mark here and here, now I could say that it's precise to the nearest 1/2 of an inch, right? If I put tick marks here, 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 and here, do you notice how I've divided the ruler into 1, 2, 3, 4, 1, 2, 3, 4 sections? Each one of these inches is now divided into fourths, and so I could say that the ruler is precise to the nearest 1/4 of an inch. And I could keep this going. I could make more tick marks. Now I've divided the ruler into eighths. There's 8 sections. 1, 2, 3, 4, 5, 6, 7, 8. Now I'm precise to the nearest 1/8 of an inch. So if I draw a line here and I say, okay, how long is that line? I could say, well, it's 1 inch, and it's 1, 2, 3. I could say it's 1 3/8 inches long, approximately, because that's the mark it's closest to. And if I make it a little longer, somebody might say, no, that's 1 4/8 inches, which is the same thing as 1 1/2, 1 1/2 and 1 4/8. If I make it a little bit longer, somebody might say, oh, that's 1 5/8 inches now, okay? So that's precision and your assignment. But the next thing that they talk about is something called significant digits. Look at page number 591, and you're going to need to go down about 2 inches. There's some rules that they want you to be aware of there that talk about how we figure out how many significant digits a particular number has. I'm looking at that column or that section where it has 1.23 and it has 10.05 and it has 0.072 and it has the number 50.00. And it's telling you how many significant digits each one of them has, and it gives you these particular numbers off to the side. And what's very important is the blue writing over here on the side to help you figure out why they're claiming that this number has 3 significant digits, this one has 4, but this one only has 2, and this one has 4. Okay? Pay real close attention to those rules as I go through some numbers. If I write on the board 1,040, would you be able to tell me how many significant digits that has? Well, the answer is that it has 3 significant digits. Why? Because this last 0 is not considered significant, but these digits are. What if I wrote the following number, 0.003? How many significant digits would that have? That would have just 1 significant digit. How about 90.051? That number would have 5 significant digits. And how about the number 0.6300? How many significant digits would that have? That would have 5 significant digits. Actually, I'm sorry, no, it wouldn't have 5, it would have 4 significant digits. These are the significant digits there, here, here, and here, according to those rules. Let's try some other numbers. My book was wrong on that one. Okay, what if I wrote 80.4? That would have 3 significant digits, because all of them are considered significant. How about 0.09? That would have just 1 significant digit. How about the number 6? That would have 1 significant digit. How about 6.0? That would have 2 significant digits. How about 6.00? That would have 3 significant digits. How about the number 1005? That would have 4 significant digits. How about the number 0.0012? That would have just 2 significant digits. Remember, we're doing this according to the rules that are listed near the top of 591 in the blue writing, and then up above and below the black writing is going to be helpful in figuring that out. How about if I wrote the number 1,500? That would only have 2 significant digits right there and there. But if I wrote 1,500.4, now that number has 5 significant digits. All of those numbers are considered to be significant. If I wrote the number 12.7, that would have 3 significant digits. If I wrote the number 1,270, that would also have 3 significant digits. The 0 is not considered to be significant. Hopefully that helps you with that middle section. The bottom section of your worksheet, be very careful. There are different rules for how we handle adding and subtracting of numbers and how we handle multiplying and dividing numbers. Look at the rules on the bottom of page 591 for adding and subtracting. It says, after the green writing on 591, when adding and subtracting measurements, the sum or difference should have the same precision as the least precise measurement. So if I have these numbers, 12.467, 13.2, 28.14, and we'll call it even on that. That's enough numbers, and we're adding them up. The first thing we do is we do the adding, and so I'm working on that. I get 53.807. Then we look and see how many decimal places each one of these numbers has. This has 3, this has 1, and this has 2 decimal places. So I'm going to make my answer have the same amount of decimal places as the number that had the least amount of decimal places in our problem. So the answer in this particular case is 53.8. This is the way they want you to do the adding and subtracting problems in the bottom of your worksheet, which is different than how they want you to multiply numbers together or divide numbers. Okay? So when it comes to adding and subtracting, your answer is going to match the answer that has the least amount of decimal place values. Okay? Let's try it again with a different one. But this time, it's going to be a subtraction problem. Let's say I'm subtracting 14.879 minus 2.46. Okay? I would do my subtraction, and then I would look, oh, this has 2 decimal place values, and this one has 3. So I'm going to make my answer have 2 decimal place values, the smallest amount of decimal place values. And in this case, that means writing it as 12.42, because I'm going to look at this 9, and that 9 is going to tell me to round up to 2. So here the answer is 12.42. Okay, that covers adding and subtracting. How are we going to multiply or divide? Well, the rules for that are on the top of the next page, 592. It says when multiplying or dividing, the product or the quotient is going to have the same number of significant digits as the measurement with the least number of significant digits. What in the world does that mean? Let's say I have 10.2 and I want to multiply that by 4.5. How many significant digits does this have? It has 3 significant digits. How many significant digits does this have? It has 2 significant digits. So I'm going to solve the problem first. Excuse me. And I get 45.90. 45.90. But looking at the amount of significant digits of each of these numbers, this tells me that I need to change my answer so that it only has 2 significant digits. What number is closest to this that has only 2 significant digits? That would be the number 46. So that's my answer, 46. Notice how this is a little bit different. We're thinking about significant digits. Let's try a division problem. Let's say we were dividing 147.5, and we were dividing that by the number 5. This number has 4 significant digits. This number only has 1 significant digit. Let's do the math. 2, 9, 5. Okay, so I have an answer of 29.5, but I need to change this answer so that it only has one significant digit. What's the closest number to this that has one significant digit? Well, that would be the number 30. So the answer to this problem is 30. Hopefully, 8th graders, this helps you.